Anyway, hello everyone. My title is Plan, Apply, Commit, and whoever here heard of Terraform might get an idea what it's about. So that talk is about building infrastructure with Terraform, and there was something else here, but it doesn't appear in Windows XP that is here. So we're going to talk today about why we're using Terraform and why we chose it in the first place. We will describe the building blocks of infrastructure. We will talk about the way we run infrastructure, and we will tell as well how we can be cost effective when it comes to operating infrastructure. Who am I? I'm a principal platform engineer at ITV. I work with some nice colleagues, and the image, right? Yeah, that's two spaces. So that's me. I'm for about 3 years at ITV, and I have seen all the modernization projects that happened in the past 3 years, and they are mostly migrations from a legacy state on-prem to the cloud. So let's start. Here it is. Anyway. This is our goal. So ITV, I think we're like a big company, and there are different product teams that I see them as small startups. By product teams, I mean completely different teams, but probably they don't talk between them. They are responsible for the website, one team, another team for maintaining legacy systems, another team for managing payments for front and deck. But they all share a platform engineer. So it is our responsibility to be embedded in the team and help them design, build, and operate their infrastructure. What is infrastructure for us? First of all, infrastructure, the last 2 years at least, lives in AWS. So we are AWS customers. Responsibility for us is to help developers by giving them CI pipelines to deploy their applications in different environments. We need to collect logs from whatever we're creating, and we need to collect metrics as well, business metrics or application metrics. We also need to provide monitoring and alerting, because a product team needs all these things in order to go live. So our go live checklist needs to have all these things, and we should do that in an automated and secure way. By automated means reproducible way. So if something happens, I need to be able to do it again. And because we live in AWS, I need to be able to do it either in Ireland or in London or anywhere, any region. So I'm going to talk how we start building infrastructure. First of all, we are a huge fan of infrastructure as code. And by code, mean everything should be treated like we treat software. So if you're going to create a new software and you're going to use Git, for example, everything starts in a repository. We call that the infrastructure repository. There are 33 product teams in ITV, different technologies, one team with Scala, other teams with Node.js, different teams. There are 33 different product team repositories for their infrastructure. That limits the blast radius, which is very important. So a change from one team doesn't affect someone else. Obvious, but it wasn't that in the past. In the past, we used to share a big repo for everyone, and that wasn't nice. So we changed that. And we can also define who is going to access certain things, which is good. Why we choose Terraform? Because we did our first modernization project in AWS, and we started using CloudFormation. It was okay. We wrote some custom wrappers around it. It wasn't nice. 2 years ago, you were writing something, you were executing it, live in AWS, it was a bit slow, and you didn't know exactly what will happen. So we didn't like that. We wrote a lot of custom wrappers around CloudFormation, which is the official way from Amazon to manage. Yeah.
Do you mind telling us what Terraform is?
Yes, I will come to that. I'll come to it. Yeah. So initially, we created infrastructure in AWS using CloudFormation, which is the Amazon product for combining all their services and their API, and is a JSON thing. It doesn't look nice, but it can be templated and you can do it nice. We didn't like CloudFormation, and then there's a company called HashiCorp, which created a tool called Vagrant, which is quite famous in the dev community. And what allows Terraform to do is you write your code, and Terraform has providers to talk with multiple APIs, AWS API, Azure API, OpenStack API, and many other APIs. But there are 3 official supported, AWS, OpenStack, and Azure. And it essentially translates your code into API actions and makes a plan. That plan is a series of actions, and if you want to create a server in AWS, you write your code for that, then you create the plan, and Terraform tells you, I'm going to create a server in AWS. Are you okay with that? Yes, I'm okay. And that is the only thing that's going to happen. And the good thing is, at the end, it gives you a state. And says, okay, here is your existing state. And your existing state at that point contains that single VM in AWS. And that's good. You can start adding things on top of it. And this is why Terraform works nice for us, because we can create a plan. So, and we can review it. For example, I can ask a colleague to review it. And if everyone is happy, we can apply it. And you can move that later on in your CI. And then you can have, I create a plan, and then someone else approve it and press apply. And that is really nice. We started using it almost 2 years ago when they released their first version, so we started playing the very beginning. And we moved our first product in production about a year ago.
Sorry.
Yeah.
Okay, so disrupting. Is this a code management application, or is it an infrastructure management application? Is it like Docker, or is it like?
No, it's not like Docker. Yeah, it can manage Docker. It manages infrastructure for you. And by infrastructure, I mean it has a concept of providers. So there is a provider for AWS. There is even a provider for Docker. So if you want to manage Docker containers, yes, you can manage them with Terraform. But we use Terraform to manage AWS resources. And for every AWS resource, Terraform has a provider that needs to support that resource. So all you need, for example, if you want to create a server, there is a piece of code that you can template, you can modularize. And this is what Terraform is. It's a tool from HashiCorp. And I really advise you to have a look. It's really nice. Moving forward, I wanted to give you an overview of what is an AWS product for us. Because we build infrastructure in AWS, and we do that for at least 20 or 30 different product teams. This is by product. For example, one product is the ITV website. It's a separate product. There are 2 AWS accounts. It's a dev AWS account and a production AWS account. Within these accounts that we call ecosystems, the dev ecosystem and the production ecosystem, there are environments. In the dev ecosystem, we have all the environments that developers need for their application. QA, SIT, staging, and everything lives in one AWS account. We call it the dev ecosystem. There are multiple VPCs that is the actual environment is a VPC. And we have the infrastructure VPC in every account. The infrastructure VPC is where we host things like our CI, Jenkins, we use Jenkins, where we host our logging, our Elasticsearch cluster, console, sensor for monitoring, and it's a VPC just for infrastructure. And going to production, we have another infrastructure VPC for production that hosts.
Yes.
VPC is an Amazon term of describing a network segment.
Okay.
Yeah. So,
Sorry.
sorry?
Like a virtual host.
Not a virtual host. It's like a network. It's like a virtual network. For example, it's like when you are in your home and you have
Sorry, a virtual machine, like a virtual.
No. It's a network segment. For example, if you are in your home, you have a network 192.168. So a VPC is essentially a network. And by being a network, you can have instances inside, and they have addresses. So all these are, think of them as network components.
Okay.
So the VPCs are network components.
Yeah.
And they're isolated. Yes. And because they're network components, you can link them with your on-prem network by using routers and VPNs.
Yeah.
And this is how we create a product account. So our AWS consists of two accounts, a dev and a prod account. Makes sense. The dev contains everything that developers need to build their application and test it. And the production account is the final product, where we deploy the application.
How many instances are there for each one of these accounts? Is it one developer instance for each developer, or one for all developers?
We don't have that need. So we have a pipeline, a CI pipeline, and they do a commit, and there are some tests, and it will arrive in one environment.
Right.
Then they don't have a per developer.
Right. Okay.
There's also need.
No. Understood. So it's one instance for all developers.
Yes.
Understood.
And that's our view. So, talking about Terraform, you treat your infrastructure as code. If you want VMs or network components, you write code, and you create a plan. And Terraform tells you it's going to create 10 VMs, and then you apply it, and then you can commit that in any source code repository. We use Git and GitHub, and you have a nice clean view who did that when. And we also store, because as I told you, in Terraform has a state of all the things that it's creating. We host that in S3. S3 is the Amazon service for storing objects. By objects, I mean a file, and because Terraform state is just a file, we store that file in S3. S3 allows us to use versioned objects. So we enable versioning in the S3 bucket, and we have full view of every change that is applied in the infrastructure. So if I want to audit it, I can audit it from the very beginning till today. And it's very nice to see that. And can also save you if you want to do rollbacks and other things. If you want to access state from another account or another product, Terraform has a thing that is called remote state. And essentially, it's you define a piece of code that says, okay, I'm the dev account, and I want to take a variable from the production account. And the state can communicate, let's say, and you can grab that value, which is very useful if you want to develop against the resources in another account. Terraform essentially is a binary. You download it, you write Terraform, and it gives you a usage. So lots of people who use Terraform, they write custom scripts around Terraform wrappers. So we wrote our own wrapper, and it works for us. It manages encryption for certain values or authorization to access AWS resources. But there are many ways of running Terraform. And because it's code, we can create modules in Terraform. So if you create, if you have an application that requires a virtual machine, let's say in Amazon, instead of defining that every time you need it, you create what we say a module. We define what we want there, and then we accept some inputs for that module. For example, if you want to create a VM with a certain size, let's say 15 gigabytes of RAM, that matches to a certain AWS instance type, and you can pass that as a parameter to the module. So every time now you want to use an instance, you just call the module from your code. You actually reference the module. And these modules, they manage AWS resources, and we treat them again as software. We store them in GitHub, and whenever a product team wants to use a resource from AWS, it just references the module. We wrote it once, and then we iterate. To give you an idea of how our Git repository looks, we have a Terraform folder that we contain the dev ecosystem and the product ecosystem. And by that is what I described earlier, our segregation between. Yeah, much better. And then within every ecosystem, for example, dev, you can see infra dev, QA, states. And inside QA, there is the actual code. The .tf is the extension of Terraform. And that main .tf contains all the code, which essentially is references to the modules to create infrastructure. And it might be a bit strange if you haven't used Terraform, and I apologize for that, but I just wanted to show how we do it, and you might get an idea.
Could you give us an example as to what sort of thing would be in a module? What sort of
yes,
modules you have?
So the modules are here. We have a vendor folder with some modules. And a module, for example, is Route 53. Route 53 is the Amazon DNS service.
Okay.
So if you create a server and you want to assign a name for whatever you are creating, we have a module that accepts as parameter what name you want to give and an ID. So if I want to name what I'm creating, I'm calling that module. Same way, if I want to do subnets or a VPC, so the VPC is a module. We have a module to create that VPC. So that little piece of thing that we call a VPC is created in Terraform. So every product team references that. So essentially, is we're referencing things, we provide the correct parameters, and we run a plan, and it says we're going to create this, and boom, happens. I'll give you an example. I'm not sure if you can see that, but this is a git diff in the file. The green thing is I'm calling a module that I call it Drop Wizard. This is one product team. They are Java developers using Drop Wizard for development. And I wrote a module that I call Drop Wizard, which essentially is a combination of 3 other modules. And I just added some parameters. For example, instance type, T2 medium. This is one of the smallest Amazon instance sizes. And some other parameters, like security groups, which makes sense in the Amazon world. And so I did my change with my favorite editor, and then I ran Terraform plan. And Terraform tells you that 6 resources to add, 0 to change, and 0 to destroy. At that point, I know for sure that the next step will be at least to create 6 things in Amazon. I know what these things are because I wrote them, and I can see them here. It tells you that I'm going to create a DNS record called with that name, and it's exactly what you want. And the next step is to apply that plan with Terraform Apply. It connects to the AWS API, issues all these commands, and it tells you again, apply complete, 6 resources added, 0 changed, 0 destroyed. If you suddenly see 100 resources to destroy, that means you did something wrong. Yes. I have seen that. But this is like a human error, and you can prevent it. But with CloudFormation or other tools, we didn't have that visibility. That you make a change, there's a plan that's I'm going to connect to the AWS API, and I'm going to apply these changes. And that really helps. And at that point, the state is refreshed in S3 and contains all these resources. Next time I run a plan, is I don't want it. It's not going to create again, because it will refresh the state with what is in the code. And Terraform is intelligent on doing that. This is an example of a module we have in Git. It's called ASG ELB, which means autoscale group plus load balancer. ASG is an autoscale group in Amazon, which is the Amazon way of autoscaling. And ELB is a load balancer. So that module essentially creates that and has some parameters. And you can see here that we're using, this is coming from the change log. So we treat that module as software. We have a change log. We use semantic versioning. For example, version 8 was a breaking change, and whoever wants to use it needs to read that description and says what changed. And if there's a bug fix, 801, if there's a feature, 81. So the users, which is platform engineers like myself, I will go and see the changes. I can also do a pull request and change something. And so now we have all these modules. We need a way to bring them together in our infrastructure. And Terraform didn't have a nice way of doing that in the beginning. So what we did essentially is we created a YAML file that we call it the Terra file, which is similar to the gem file in Ruby that manages dependencies and all other dependency management. So essentially we reference a Git repository with a version. And then there is a loop that goes through the YAML file and check out the modules in the vendor folder. And this is our way of checking out dependencies from Git to our repository. Other people use submodules, but it's up to the team, whatever. And that works for us.
Sorry, just quickly.
Yes.
When you said use submodules, you meant Git submodules, not?
Yes.
Yeah.
But because we are in AWS, we're nothing without an AMI. An AMI is a machine image, which is essentially the base for your infrastructure. So we have a way to build infrastructure with Terraform, but we need to have an AMI. And talking about our life cycle for the AMI, important thing is there are 20 or 30 different product teams that they are going to use that AMI. So we have a challenge of being consistent there. We don't want one product team to use a CentOS AMI, another use an Ubuntu AMI, another use something else. So we enforce that centrally. So we build every Sunday night, our Jenkins builds an AMI. We enforce a security policy from CIS, it's called CIS benchmark, which is essentially a checklist that we enforce during the creation of the AMI. So we create a golden image that has the blessing from security. And we share that image with all the product teams. And if we want to patch for a vulnerability, let's say Shellshock was last year, what we did is we just built a new AMI. We don't have to go through servers and manually patch. We built a new AMI. We let everyone know that we have a new AMI that is up to date. Update immediately. And when you want to roll the new AMI in your infrastructure, we made, in the beginning it was a bit of a manual approach, but now it's part of the pipeline. So we press a button in Jenkins and slowly upgrades the AMI to everyone. And that gives us consistency. So every product team in ITV uses the same AMI. And that's the first place I've been that managed to do that. It is a very hard thing to do, being consistent. And we had a big problem being consistent not only with AMI, also with naming. I'm not talking about that, but naming was a very difficult thing. We now have consistent even with naming, which is very good.
So can you give us an idea of the scope of things that are defined within your MI? Is it the operating system?
Yes, so we use CentOS.
Right.
CentOS 7 is our choice.
Right.
So the core AMI is created with a tool called Packer.
Right.
Again from HashiCorp, same company that created Terraform.
Yeah.
And we define that again as code. Everything that is inside that AMI is code.
Right.
And you know exactly what's going to change.
So every single instance is running on the same version of CentOS.
Yes.
With the same patches.
Yes.
And it's upgradable.
Yes.
As and when you need to.
Yeah.
Right.
And if that is old, you get an alert. We're not allowed to leave machines over 30 days. We get an alert in our monitoring system that your image is old, do something. So the platform engineer who is embedded in that product team has a task to go and upgrade it. Now, so we're in AWS, we're excited about being there, so we start building things. In the beginning, you build without thinking how much things will cost. So,
and then you get to build from Amazon.
yes, so me personally, I don't pay the bill, but my boss tells me, we need to do something. So, obvious, developers, they don't work overnight, right? No, they don't. Shut down the dev ecosystem overnight. In the diagram that has the dev and the prod account, everything in the dev account doesn't need to be up during the weekend or non-office hours. So we shut it down. So we save at least a lot of money. For the ITV scale, that we have more than 60 AWS accounts with that convoy production and dev, that's a lot of money. We use spot instances, which is an AWS terminology of describing bidding in server capacity. So that's one way of saving money, using spot instances. And we also monitor our capacity. Do we really need that large instance, or we can live with a lower spec? So we monitor that, but we didn't start monitoring it. We started, with high expectations, but then we realized that we need to do it properly, and this is how we did it. Shut down their environments is the easiest thing to do, and we have integration with. We use Slack for communicating. So 8 o'clock, the bot tells, I'm going to shut down the dev environment. If you use it, you go there and you cancel the job because you want to use it. And it's like last person close the door. So if you finish it, you just press power off. And then next morning, 8 a.m., they start. When they start with a fresh AMI. So if, for example, you build an AMI Sunday night, Monday morning, your infrastructure, the dev infrastructure, will start using the new AMI that you built last night. So you can test it Monday morning. So if there is any problem, you will see it in the beginning. That process of building up all the infrastructure had some problems, but because we automate a lot of things, we are now okay and we are confident. We shut down things, bring up, which is very nice. And that saves the business a lot of money.
Do you know what percentage of money you save on your AWS costs? Approximately.
Thousands of pounds. I can dig some numbers, but I don't have the exact numbers in my head. But I know we save a lot of money. Because if you shut down, the dev ecosystem runs half day. So it's like half of the money you pay for the dev ecosystem, you don't pay them now. Because you only power it on for 12 hours during the work you do.
So was that percentage?
Yes, I don't have that number, sorry.
How long does it take to power up, power down?
About 20 minutes.
So
The power down is immediately. It's like
power up is
it takes about 20 minutes because the configuration management runs to configure every box, and that means Some things they come up in 10 minutes, some things come in 20 minutes, depending the.
Does that mean that if you do have an emergency situation, that it actually takes you 20 minutes to respond in a dead environment? Test things in a dead environment.
In a dead environment? No, because.
That sort of affect your, give you guaranteed
no,
downtime of 20 minutes.
No, the 20 minutes is just for the components that they are heavy. Like, for example, if we terminate our CI, which is our Jenkins, it's our biggest instance. So it needs to check out lots of dependencies from the internet and also configure jobs. But for the actual microservices application, it starts up immediately in less than 10 minutes. So when it comes to production, let's say we lose an instance, it will take less than 10 minutes for a new one to come up. But we have ways of mitigating that. We have caches in front, we have 3 of them, we never run just one. So we have 3 instances across all availability zones. So even if it takes 10 minutes or 20, it's not a problem. But we always try to reduce the numbers. So that's why we started using VMs. If later on we move to containers, that thing will be like that. But that's the migration from on-prem to AWS. We didn't migrate from on-prem to containers. But that works for us.
And is Terraform managing all this as well?
Yes. We have a Jenkins, our CI, that manages all these tasks. Part of our.
How do you deal with, you've got different project teams, and if different project teams are working with applications that require different sort of operating systems or whatever it might be, or different versions.
We don't have that. We don't have that. Everyone is happy with CentOS, and because most of our stack is either Java developers or Scala developers, we don't have that. There is some Windows team.
We used to have where you had one team working on one application and they want it in like this, and the other guys want it like that, because they're doing it different different applications.
From
the malware versus.
So we are called the Common Platform team. Our task is to run all the product infrastructure. We can't really support. I mean, we have the knowledge to support different operating systems, but why do that? So consistency. And that really helps us when it comes to people come and say, oh, I want to run Ubuntu, because I know Ubuntu. Yes, okay, we can run Ubuntu, that's not the problem, but the rest of the company, which is it's not small, it's a big company, uses CentOS, so why do you want to be different? If there's a very good reason to be different, we will consider it centrally. Same with our choices when it comes to tooling. Terraform, for example. It went from a lot of testing before we decided to use it. So how we run that infrastructure we create with Terraform? In AWS we have autoscale groups. So if something dies, it will come up again. And we use configuration management to ensure that the state will be the way we want it. We recycle instances regularly. This is what Netflix calls Chaos Monkey or Gorilla, which is randomly kill an instance. And we do that. Before I come, I recycled some instances just to test and prove to myself that they will come up nicely and clean. Because Amazon may kill them. Now that we are in AWS, we don't have record uptimes. I remember when I was working in legacy providers, I had legacy system with uptime of 1,000 days or more. No, we don't have that anymore.
Did you kill them in production?
Yeah. I don't go and kill them in production on purpose, but when I do an AMI deployment, I kill them. I don't do it like Netflix. Actually, we don't do it like Netflix. That they randomly kill a zone. But nothing stops you from doing that. We're pretty confident with our configuration management. So we monitor the infrastructure. We use Sensor for monitoring. It's a cloud-friendly monitoring solution. We have infrastructure dashboards with Grafana and Kibana. There are 2 products that we use. Our logging and metrics are hosted in the Elk stack and InfluxDB buckets. So our logs go to Elk, metrics go to Influx. And everything, as I said, lives in that infra repository. So blast radius is limited, and all your changes are in that repository. And this is something which is very helpful. We get, because we template everything, we get templated graphs whenever we create a new server. They come for free. And because we have all these components modular in Git, if someone comes and tells, we want infrastructure for that product, that's easy. We create a skeleton, and that essentially is an array task, which is just a script of you run it, you give it some parameters, and it goes through the modules and gives you an infra repository. And I press plan, and I have infrastructure for a product in AWS in a few hours, compared to having it in weeks or days in the past. And it's very nice because it's something we're proud of. So that's why I'm here to talk about it. So let's recap. Infrastructure is code. We need to treat it as code. Version it in Git is important. If you can use a changelog, really helps. I know it's hard to maintain, but if you do it once, you will see later on the benefit, especially when new team members join. It's very nice. We share everything. If a product team creates a solution for something, it's in GitHub, and we try to share it. Blast radius is very important. We used to have a single product repo, and all the different products were using that. So a change that I did for something might affect something I wasn't even aware, and that wasn't good. Terraform plan and apply is really awesome. It gives you a view of what is going to change. And the Terraform state is like a live CMDB. If someone tells us, what you have in your AWS, it's in my state. Nothing else is allowed to configure resources in AWS other than using Terraform, and we enforce them. We use the core AMI centrally, so all the product teams, the same AMI. I know it's difficult to enforce it, but we did it. It worked. Shut down pre-production overnight or weekends. If you do that, you automatically save money, because there is no point of having instances running without someone using them. And obviously that's in the dev world. In production we don't. And with all these components version in Git, we can create a product skeleton, and a product team can use that to create infrastructure in a few hours, which is very good. So, any more questions?
So how does Terraform compare to Vagrant?
Is different. So Vagrant is a wrapper on top of VirtualBox. VirtualBox is a way of creating VMs. And Vagrant essentially uses the Vagrant file to describe how VMs are created. You could use, let's say, the Vagrant file to describe AWS resources, but it's not a nice way to do it. Terraform is a bit more advanced, and it uses the concept of providers. So if you want a provider, for example, to create an instance in Azure, and then have a DNS entry in DNS, from the same code, you can reference both resources, and you can say, okay, I create a VM in Azure, it gives me back an IP, and then I'm going to update the record in DNS. So different providers, different APIs, together with one tool. And that's Terraform is powerful. We create, you can create databases if you have, let's say, Postgres or something, or if you want PagerDuty alerts or GitHub repositories. The community creates APIs for providers for all major products.
Your wrappers, are those wrappers that are written in Terraform language as well?
No, the wrappers, because we mostly write Ruby, so essentially we wrote the wrapper, it's a gem file, and it's a wrapper along some commands like Terraform plan with all the parameters. So instead of, it's called DOM, which is, when I want to run the plan, I just run DOM -p, instead of running Terraform plan, blah, blah, blah.
So those, that code directly interacting with Terraform, or is that through?
It calls the binary. It doesn't interact directly. It sets up some environment variables, and because Terraform can use environment variables to reference variables inside the code. So, if, for example, we have a secret, a password. We don't want to commit that password in GitHub, right? We don't do that. So what we do is we encrypt it, and during the Terraform plan, Terraform decrypts it, stores it in an environment variable that lives only for the duration of the plan, and use that variable to. So essentially, it's a way of calling Terraform. We are not messing with Terraform.
Now there are sort of wrappers in other languages that.
Yes, a famous one is called Terraform. There are different ways, different people that just a simple shell script, and there are people that they don't have the needs we have, and they are happy just running Terraform plan and apply, and it's up to the team.
How similar are your product teams in terms of what they're producing? So you've described that the technology they're using is different, but the platform is obviously the same. So how similar between them are they?
They're not similar at all. They can be completely different. For example, the ITV website is a PHP stack. And
What, sir?
PHP.
PHP.
Sorry. But our Samsung TV application is HTML5 JavaScript. So the stack is completely different, but the platform is the same. They both use Jenkins for the pipeline. They both use Elk. They both use, the application VPCs contain different things, but everything else is the same. We have Scala themes, Scala microservices, Java microservices, all kinds of things. There are little startups within ITV, so I can discover every month something new. Multiple locations across UK, and there are different challenges, but the infrastructure is the same.
But they all sound very similar. I'm not hearing the need between soft real-time and hard real-time systems, for example, like examples where you might find the requirement to tune kernels or to start tinkering around with ephemeral port ranges and stuff like this. You don't have those issues. And now I'm hearing, okay, yeah, this is how you get consistency on the plan.
Yes.
Thanks.
You keep describing platform as code, and this, your AI, which you can change and deploy, clearly the applications running on top of that have a dependency on it, and so AMAI changes, I can imagine, can break some microservices and so on and so forth. Do you have automated tests from when you're rolling those sorts of changes through?
Everything starts in the dev account. I will use a UMI in the dev account. If it works, I know that it works there. Because we use configuration management to create the same thing that lives in dev is in production as well. So we are confident. Plus, we're doing blue-green deployments. That means we create something, we use Terraform to do blue-green deployments as well. We create something on the side, we test it, we verify it works, and then we just take that autoscale group and move it to the production of the bunch. And if it works, we kill the other one. So even if the AMI, it can happen. It can be a different thing in production that we never thought about it, but we will catch that during the deployment phase. Because we're not deploying on top of the live server, we're deploying on the side, we test it, and then we switch traffic.
Who do you allow to make Terraform changes? So is it just platform team, or do developers themselves also make Terraform changes?
Developers, they do changes, yes, but it's up to them. And there are developers that they're really passionate about how infrastructure works, and there are developers that they're not so passionate. The passionate ones, they have discussions with the platform engineering teams, how it works. And there are some product teams that if they want a new microservice, they just do it themselves. And they obviously ask for review. So what they will do is they will create the code, they will do a pull request, I will review it, and I will run the apply. And that way we can have, we know what's going on. But they do that in the dev world. But in production, obviously, we have more control and we are doing the changes.
So do you keep control of the cost, the footprint that you're actually executing in the cloud?
Yes, and this is a task for my boss. It has, the control panel, for the bills, and as a whip.
So that developers don't get the free hand to spin up instances as and how they see fit?
We have what we call the playground account. So there was a team that we were experimenting with AWS Lambda. So they have access to an AWS playground account. They go there, they do whatever they want to do. Obviously, they don't create, GPU instances that they cost £2,000. So they have control over a dev account, but in the actual product account, no.
What are the alternatives to Terraform?
Alternative Terraform, that's a nice question. Obviously, if you're in AWS, it's CloudFormation, which is the official way of Amazon doing it. There are wrappers on top of CloudFormation, and other alternatives.
So the other question is, I presume it's a licensed product. So how?
This one, Terraform.
Yeah.
No, it's open source.
Open source. So how does it cost you anything to zero, apart from just the time to understand it?
Yes.
Okay.
It's an optional product. Sorry, forgot to mention that. HashiCorp tooling is open source. They have an enterprise way of running Terraform, but we use the open source version. And every tool we use in that platform stack is open source. Puppet open source, Elk open source. No open source. We don't use the enterprise versions of products. We manage them.
HashiCorp can do a sort of enterprise support for Terraform, don't they?
Yes, they do. They have a product called Atlas.
Atlas,
Yeah. Essentially, we try to do something similar in our CI. Every time someone does a pull request, it will create a plan. If the plan is successful, in GitHub there's a nice way of getting notification with best pass or so something similar with plan. Whenever you press merge the pull request, an apply will happen. But we're still working on that. This is called a pull request driven infrastructure. So you create on the merge, you apply the change, but